So today we'll start with relations and functions. So these two are connected topics. So that's why we first need to discuss relations before moving on to functions. Okay. So I guess you must have studied this thing in your 11th standard. Relations, set relations, right? And you must have a brief idea of functions. What are functions, right? So let's study in detail. So first we have a set. So let's first discuss some definitions. What is a set? What is a set?
Collection of things.
Yeah, a well-defined collection of collection of things, you can say, or objects, or if you want to use a mathematical term, so it can be elements. A well-defined collection of objects or elements. Okay, you can't say that this is only a well-defined collection of numbers or some alphabets or something, right? It can be anything. It can be a collection of cars or something, right? But in maths we have to deal mostly with the numbers, okay, instead. And so there are two forms to represent a set. Do you remember? What are those?
Set builder and roster.
Yeah. So there are two forms. First is roster form, and the second one is set builder form. So what happens in roster form? Let's suppose you want to define a set for factors of 12. Okay. So roster form will just give you all the factors of 12, which are 1, 2, 3, 4, 6, and 12 is also a factor of 12, no? So these are all the factors of 12. And what will you get in set builder form? Can anyone make?
Such that
X such that?
12 divided by x gives 0.
Okay, that's one way of writing it. 12 divided by x is a natural number, we can say that, right? If you divide 12 by this number x, you will get a natural number. And x is also a natural number. Or what we can say is x such that x divides 12, x being a natural number. So these two are representations in set builder form. Okay. You can also write it like this: x divides 12 such that x belongs to n. And then you have some different types of sets, like empty set. You must know. Empty set is a set which have no elements. Okay. So empty set, you just need to remember that how to represent this empty set. This is represented by phi, okay, or you can just put two curly brackets with no element inside it. Okay. These are two ways of representing a empty set, an empty set. And then the next thing is singleton set.
Only one element.
Yeah. So such sets have only one element. The main thing which we need to discuss is a subset. So what is a subset?
A smaller set
Okay, a set which,
satisfies a particular condition.
what condition? All the elements?
Maybe all or maybe
Yeah.
none.
So you can say that a set which contains some / all the elements of a given set. Now see, subset itself has no definition. It has to be linked with a power set or a bigger set, right? So we can say that A is a subset of B. We can just not say that A is a subset. Okay, that makes no sense. So of a given set, let's say B. So the way to represent it is, let's suppose the set is A and it is a subset of B. It is represented like this. A is a subset of B. Okay. and then you have a proper subset.
Hmm.
What is a proper subset?
Which contains all the elements contained in the.
No, that is improper subset. So proper subset is a subset. Now see, in the case of subset, have you written this? Okay. Let's see what kind of subsets can be formed. Let's suppose this is B is equal to 1, 2, 3, 4. Okay. So we have a different subsets. They can be like this: 1, 2, 3. Okay. This has some of the elements of B. Okay. Then next we have A2. Let's suppose it has all the elements of B. Okay. Then also we can say that A is a subset of B. If it has just one element, then also, and if it has no element, then also it is a subset of B. Okay. So all these are considered to be subsets. A1, A3 and A4 are proper subsets. Okay. So the condition for proper subset is that,
Elements, number of elements should be lesser than.
yeah, you can say that, or all the elements should not be identical. Okay. Because if this is a subset, this is a subset, right? But this is improper. Why? Because this is the set itself. Okay, this does not have lesser elements than the given set. So in case of proper subset, you can say that proper subsets A is a proper subset of B. We write it like this. How is a null set a subset of every set? Now see, null set, you can say that now see, null set has no element. Okay. Now while counting subsets, the condition given is that it should have the equal numbers or lesser numbers. Okay, it can go up to 0. Now while counting the number of subsets, what strategy we use is, let's suppose we have n elements, A1, A2 up to An. We have such n elements in a set, in a given set. To form subsets, we can either use all the elements. Okay, what is this NCN? Yeah, so this is binomial coefficient. This means selecting n elements out of n. Okay, or you can choose n minus 1, or you can choose n minus 2 up to NC1 and NC0. Okay, so do you remember the sum of this series?
By n minus 1.
No, 2 to the power n, just 2 to the power n. Okay, so the sum of this series is 2 to the power n. So the total number of subsets will be 2 to the power n. Okay, so the condition for the subset is that the number of elements should be lesser than or equal to the given set. So therefore 0 is also lesser than the given number of elements. Okay, therefore the null set is also a subset. Okay, now the condition is that all the elements of a subset should be present in the given set. Now since this null set has no element, so obviously its elements are present because it has no element. Okay, that's this simple. So in case of proper subsets, A should not be equal to B. Okay, that is the condition for a proper subset. So the number of proper subsets will be 2 to the power n minus 1, because we are just skipping one subset, right? And how you get this formula? Do you remember? How do you get this formula? Okay. What about this expansion? what is this expansion called? Binomial. So you have this expansion. Okay. What do you want here? NC0 plus NC1 plus NC2 plus NC3 up to NCn. What you can do here is, you can put
As one.
x is equal to 1. When you put x is equal to 1, you get 2 to the power n over here on the left hand side, and on the right hand side you get NC0 plus NC1 up to
NCN.
NCn. So that is equal to 2 to the power n. Okay. So total number of subsets is 2 to the power n. And total number of proper subsets is 2 to the power n minus 1. Okay. So next thing is Cartesian product. So the meaning of Cartesian product is, let's suppose we have two sets A, it is 1, 2, 3, and B is A and B. So can you tell me what is the Cartesian product A cross B?
1 comma A, 1B, 2A, 2B, 3A, 3B.
Okay. So it consists of, write down the definition, consists of all the ordered pairs A comma B, where A belongs to A and B belongs to capital B. Okay. Actually, this is a set. Cartesian product is a set of all the ordered pairs. So if you have these two sets A and B, then A cross B will be 1 comma A, 1 comma B, 2A, 2B, 3A, 3B. Okay. We can also show this by mapping. So what is this mapping? This is a way in which we represent the sets in this oval shapes, and we write down the elements like this. We have 1, 2, 3 and AB. And in the case of Cartesian product, every element of A will be linked with every element of B. So therefore, we get this mapping. This is the mapping. So all the elements of A are linked with all the elements of B. So now we start with relations. So what happens in a relation is that we use some of the ordered pairs of this A cross B. We can also use all the ordered pairs. Okay, but the condition is that a relation is a subset of A cross B. So what do we mean by this statement? Relation is a subset of A cross B. That out of these 6 ordered pairs, I can use 5 or 4 or 1. Okay, still it will be a relation. I can use all of them also, then also it's a relation. Understand? So if I write that I have 2A, 3A and 1B and 1A also. So this is a relation because all the elements of this are the subset of A cross B. All the elements in this relation are contained in A cross B. Therefore, this is a relation. So relation is always a subset of A cross B.
So while writing the symbol of subset, we used that circle and a line.
Yeah,
This includes improper as well as proper.
yeah. If you are definite that it is a proper or an improper, yeah. So this is for proper, and for improper, obviously, it will be equal. Okay. A is equal to B. So this contains these two things. Either A is a subset of B or A is equal to B. So in case of relations, we have three properties which a relation can satisfy. Uh, have you studied this in your 12th standard schools? Reflexive, symmetric,
Transitive.
transitive. Good. So first one is reflexive. So what is the relation which satisfies all these three? Equivalence relation. So first property is reflexive property. Then we have symmetric and transitive. Are this correct spelling? Transitive, right? So these are the three properties which a relation can or cannot satisfy. If the relation satisfies all these three properties, it is called an equivalence relation. So let's study one by one. What are these three properties? So first, we have reflexive property. If inside a relation, let's suppose the relation is defined like this, from that A is a subset, A is a set 1, 2, 3, and the relation is defined from A to A. Now the relation can be defined from A to B or A to A. Okay. Now I am defining this relation like this, that the set A is also this and the other set B is also A. So all the elements are getting linked like this. Okay. So this will be the Cartesian product where all the elements are linked with every other element of A, of the other A, right? If I get all the elements like 1, 1, 2, 2, and 3, 3 in my relation, then it is called a reflexive property. Then it satisfies the reflexive property. Okay. Like let's suppose the relation is defined like this.
If we get only 1, 1, 2, 2, 3, 3 or irrespective of others, we have these. मतलब इनके अलावा कोई और हमारे पास प्रोडक्ट भी है, ऑर्डर्ड पेयर भी है, तो वो भी रिफ्लेक्सिव है.
मतलब
मतलब एक हमारे पास रिलेशन बना 1, 1, 2, 2, 3, 3 तो है ही. उसके अलावा 1, 2 भी है और भी कुछ भी है.
हाँ, that's okay. But these three should be present. Okay. So the relation can look like this: 1, 1, 1, 2, 2, 2, 3, 2, and 3, 3. Now you can see that it has 1, 1. Okay, that is needed. It has 2, 2, and it has 3, 3. Okay. So reflexive property means that A, A ordered pair should be present. So if A, A is present, then the relation satisfies the reflexive property. Now since in A cross A, I will get 9 elements, right? Because it has 3 elements, when it will be linked with other 3 elements, I will get 9 mappings, right? So these 5 elements, the set of 5 ordered pairs will be a subset of this Cartesian product A cross A. So therefore this is a relation. And since this satisfies this property, A, A is present, it is a reflexive property. So next is symmetric property. It says that if
1, 2 and 2, 1
if A, B is present,
implies B, A
Yeah. Then B comma A must be present. Understood? So let's take an example. If you have 1 comma 2, then 2 comma 1 must be there. If you have 2 comma 2, then its opposite is already there, right? If I write 2 comma 2 or the other 2 comma 2, it's the same thing. Okay. But there's no need that all such ordered pairs should be present. So you can't say that 2 comma 3 should also be there and 3 comma 2 should also be there. So if you have A comma B, then B comma A should be there, right? Because we can see that there can be many such cases like 2 comma 3 and 3 comma 2, 1 comma 3 and 3 comma 1, right? But they need not be present in this one. They can be here or they cannot be here. But if I write 1 comma 3 here, then 3 comma 1 should be here. If I don't write 1 comma 3, then it's okay. Understood? Are you getting it? So in this case, it satisfies the symmetric property of relations. If A comma B is present, then B comma A should be present. A transitive property?
A comma B is equal to B comma C, A comma C is present.
Good. So if A comma B
Is present.
is present, B comma C is also present, then
A comma C must be present.
A comma C must be present, right? So like if you have 1 2 and then you have 2 3, then you have A comma B and B comma C, right? The second element of this ordered pair should be equal to the first element of this. Then you must have
1 comma 3 as well.
yeah an ordered pair containing all the rest of the elements of this. So you must have 1 comma 3 in this case. In this case, this satisfies the transitive property, right? And in the end, just write down that a relation which satisfies all these three properties is called as
Equivalence relation.
an equivalence relation. Right? So let's see some examples. So just tell me which of these relations are symmetric, reflexive, or transitive. So the first relation is a factor of. Now what do you mean by this is a factor of? Now there can be two sets, they will be related by this relation, is a factor of. Is this reflexive? Now this is applying for only natural numbers, don't worry.
Yes.
Is this reflexive? So what do we mean by reflexive? That A comma A should be there. So we can say that 3 is a factor of 3 or 5 is a factor of 5. So this one is reflexive. And let's say we want to check whether this one is symmetric or no. So tell me, will it be symmetric? No? Why? Yeah. So 3 is a factor of,
One.
we can say 15, but 15 is
Not
not
a
a
factor.
factor of,
Three.
not a factor of 3. So therefore, reflexive properties, this satisfies, symmetric it doesn't.
Equivalence नहीं है.
So, okay, equivalence it's not, but what about the transitive property? Just check it out.
Is a factor of 3. होगा. होगा.
Transitive है. So this relation can be is a factor of or divides.
Hmm.
It's the same thing.
Hmm.
Like 3 divides 3, 3 divides 15, 15 does not divide 3. So transitive, it will
3.
be a transitive.
3 is a factor of 15. 15 is a factor of 30, and 3 is a factor of 30.
Good. So 3 is a factor of, let's say, 15, and 15 is a factor of
30
45 or 30. Then 3
is
is
also a
also
factor of 45.
45. So if you have A comma B and B comma C, then you also have A comma C. So this one is reflexive,
Sim-
transitive, but not symmetric. So next, let's suppose you have uh, A, or let's say is a brother of. This is a relation.
is a brother.
So is this reflexive?
No.
A is a brother of A. Reflexive?
नहीं.
So is a brother of
Not reflexive.
it. This is not reflexive because we cannot say that A is a brother of A. This does not make any sense. So reflexive property is out of picture. Next,
फिर नेक्स्ट के लिए हमें डिफाइन करना पड़ेगा कि सेट जो हम कंसीडर कर रहे हैं वो सिर्फ बॉयज का है या मिक्स है.
it's not given. So in that case,
नो नॉट सिमेट्रिक.
good. So is this one symmetric?
नो.
If A is a brother of B, can you say that B is also a brother of A?
सिस्टर भी हो सकती है.
It can also be sister, right? So symmetric,
नहीं.
it's not symmetric also, because if A is a brother of B, then B can be the sister. So B will be the sister of A. And what about transitive?
होगा. ए बी का भाई है, बी सी का भाई है, तो ए सी का भाई होगा.
हाँ.
नहीं. हाँ हाँ
तो
होगा होगा.
transitive होगा.
होगा.
It will be transitive. So if A is a
हो गया.
brother of B, B C can be sister, but A is the brother. Right? C comma A satisfy नहीं करेगा. A comma C तो करेगा. A B A brother है, ठीक है ना? और
बी भी ब्रदर ही निकला क्योंकि बी सी का भाई है.
तो C पे डिपेंडेंट नहीं है. ओके, सो A is also brother. Okay. Okay. So let's see some other example. If you have A, B, both natural number, And if I give you two relations, let's say R1 is A plus B. A plus B is a natural number. And R2 is A minus B is a natural number. So can you tell me which one is equivalence? Which one is not? R1? So just tell me what all properties the other one satisfies.
R2 satisfies reflexive.
Huh?
A minus A will be a natural number.
Natural
A
number.
is a natural number.
It will be 0.
Symmetric भी नहीं होगा.
हाँ. चेक करो एक बार.
R2 will satisfy all the calculations.
So R1, let's take the reflexive property. So A plus B is a natural number. A plus A is also a natural number. So therefore it satisfies the reflexive property. If I have A plus B
As a natural number.
is a natural number, then B plus A is also a natural number. So symmetric also it satisfies. And then for transitive,
If A plus B is a natural number and B plus C is also a natural number.
then A plus C is also a natural number. So this one is pretty simple. It satisfies all the three properties. Therefore this is equivalence relation. And about this one, if we check the reflexive property, we have A minus A, which is not a natural number, right? For symmetric, A minus B,
Is minus times B.
let's suppose A minus B is a natural number, then B minus A will not be a natural number. Why? Because it will be a negative number then. For transitive, if A minus B is a natural number, B minus C is a natural number, you can add these two, you will get A minus C, which is also a natural number. Okay, so it satisfies only the transitive property. And what about the relation that A likes B?
Reflexive.
Reflexive होगा? Okay. And will it be symmetric?
Not necessarily.
Yeah. Transitive?
A likes B, B likes C.
Transitive भी नहीं होगा. Reflexive होगा क्या?
होगा.
For some it can be. Who like themselves, right? Not others. So she likes herself. Good. So relations का एक part रह गया. That is the number of relations. Right? So for number of relations, let's suppose first we have A set with m elements and B set with n elements. So how many relations are possible? 2 to the power mn. How do we get this one? Because A cross B, the Cartesian product, will have mn elements. And we also wrote that relation is a subset of A cross B. So relation is a subset of A cross B. Therefore, number of relations will be 2 to the power mn. Understood? Okay. So next, write down functions. So this is very important topic. Relations was just an introduction to functions. So what is a function? Can you tell me? How do you differentiate a relation and a function? Huh? Pre-image? Pre-image necessary? Every image has a unique pre-image. Any other condition? So there are actually two conditions, but let's just uh, make just one condition which satisfies all these two conditions, both these two conditions. So function is a special type of relation function is a special type of relation in which every element in A is, or you can say has, exactly one image in B. So it is a special type of relation in which every element in A has exactly one image in B. So first, let's see what do you mean by image. So let's say these are two elements A and B, and this is a relation defined from A to B, and relation is a subset of A cross B. So therefore, linking will be there. This is one, just one map which I'm taking out. So if I map these two, A to B, then B is the image of A and A is
Pre-image of B.
pre-image of B. Right? Also, A, capital A is called domain
Domain.
and capital B is called
Codomain.
codomain. Just write this down. So in this case, every element in A has exactly one image in B. So what are the things that are not allowed? So let's make some mappings which are not allowed here. So let's suppose we have Uh, are you able to see these dots? Yes. So let's suppose you are making the mapping like this. So this thing is not allowed because in this case one element of A has two images, but we are saying that it has exactly one image in B. So therefore this one is not allowed. Or if you have this thing, in this case one element has no image, but it should has exactly one image.
One image.
So therefore this is not allowed. Each and every element of A should have exactly one image. So it cannot have more than one image or lesser than one image. So these are actually two conditions. It cannot have more than one image, and no element should be left out in the set A. And what is allowed?
बी में कोई छूट जाए
Yeah.
और बी का कोई एलिमेंट दो से ले लो
So this thing is allowed.
बी का एक एलिमेंट टू से ले लो
This is allowed. Okay. Yes or no?
यस सर
Yes. So I'll give you examples. Don't worry. And other thing that is allowed is,
बी में कोई रह जाए
huh, that you have a vacant element in B. So let's see why these are not allowed and why this one is allowed. Let's take some examples here. So function is always defined like this, that fx is equal to something. Like you used to do in polynomials in your 900 standard, like px is equal to x square plus bx plus c, quadratic polynomial. Similarly, you have functions, and you used to make graphs for quadratic polynomials. Remember? How did you make the graphs? You put the values of x here, and the values you are getting for px over there on the y-axis, and you plot all the points, you get graphs like this, right? So let's take a simple example of fx is equal to x square, right? So for fx is equal to x square, the value at x is equal to 1 will be equal to 1, and the value at x is equal to minus 1, this is also 1. So this is a case of mapping like this, that both 1 and minus 1 are linked to 1. So this one is the case. But I cannot say that if I put 1 over here, I will get two answers. Because in the case of functions, after substituting one value, I get only one answer. I cannot get two answers. So therefore, such mapping is not defined. This mapping is not defined. This one. So it can converge, but it cannot diverge like this. So one element in A cannot have two answers, but two elements can have the same answer, or more than two elements can have the same answer. So this is the case. Have you made this? Okay, what about this one? Fx is equal to root x. What if you put the value 1? Will you get two answers? Do you get plus minus 1? Or let's suppose you put the value 4. You just get 2 plus 2. You do not get minus 2. Okay, just remember this thing and remember it very keenly, that if you have x square is equal to 4, in this case x can be equal to plus minus 2, but if you have x is equal to root 4, in this case x is only equal to plus 2. because this is a quadratic expression and you solve it by this method. X square minus 4 is equal to 0, x minus 2, x plus 2 is equal to 0. So you get two factors, x is equal to 2 or x is equal to minus 2. But the square root of a positive number is always positive, and the square root of negative number is imaginary. Good. So square root of a positive number always gives you a positive result. So fx is equal to root x. This always gives you a positive answer. So negative answer is not possible. So in case of functions, what we need to study is, step by step, we need to see some standard functions. And then after that, we need to study the types of functions. So this is a vast topic, types of functions. And while studying the standard functions, we also have to study the graphs. This is very important. So you should know how to make the graphs for functions. So let's start with some standard functions. So first one is, just write this down. These are the two topics which we need to cover. So first one is constant function. So this is very easy. Let's suppose you have fx is equal to constant c. So if you put the value 1 or 5 or 7, it will always give you a constant value, right? So like let's suppose you have fx is equal to 10. Can you make the graph of this? This graph will go like this. So this is, yeah, this is c or 10, and this will be the value. So at every value of x, you're getting the same value of fx. So all the values of x are plotted over here, and all the values of fx, which answers you're getting over here. Understood? So this part, this whole x-axis means all the permissible values which you can put in this function, all the possible values which are there. So the part on the x-axis, the portion on x-axis is called the domain, and y-axis is called codomain. But there is also one more thing, range. So can you tell me what is range? What is the range of this function? C, only C, singleton set. So the range will be all the answers I'm getting. You can say that, or you can say all the values we get. So all the answers we get, all the values we get, they come under the.
So range is a subset of codomain.
Range is a subset of codomain. Right? So in the case of constant function, it's easy. Let's see another function like this. So this is a graph of a given function. It starts from here, ends over here. So what is the domain of this function? Starting from this point up till this point. So A to B interval is the domain, because this is the values of x we are putting, right? And we can say all the y-axis its codomain. Okay, actually the domain and the codomain will be defined in the function, right? If you're given that fx is equal to x square, this function is defined from R to R. So this R to R means R is the domain as well as R is the range. R is the domain and R is the codomain, right? So A to B is the domain. Then you have codomain. What is the codomain of this?
B, 8, अच्छा, y-axis,
Codomain will be
C to D,
the whole, sorry, this whole y-axis, and then you have the range.
from C to D.
Range will be from here, C up till D. Okay, I'll explain the graph of constant function again. So this is the domain, codomain, and the range, right? So this is the first example of graph. Let's see one more example. What if you have a graph like this? Can you tell me what is the domain and range of this function?
Domain is from A to B.
What is the domain and range of this function?
A to B.
A to B and C to D. Sure? A to B, C to D. Okay. Actually, this is not a function. Can you tell me no? Why?
A की कौन पे tangent दो direction point कर
यहाँ पे?
एक particular point पे
कहाँ पे? हाँ. So see, if you take a value over here, a certain value, at this value, you're also getting this point, you're also getting this point, you're also getting this point. So at the same value of x, you're getting three values of fx, which is not possible in the case of a function. So this is not a function at all, this is a relation, not a function. Okay. So just write down one note. To check whether a relation is a function or no or not, draw a line parallel to
x-axis.
y-axis, parallel to y-axis, right? If it cuts graph at more than 1 point, it is not a function. Understood? So if you draw all such lines, you saw over here that it is getting three different points. So if it is getting more than 1 point, it is not a function. It's just a relation. So first graph which we discussed was the constant graph, constant function graph. So in the case of constant function, we have fx is equal to c. So can you tell me what is the value of f1? This is equal to c, because this function is not dependent on x. So it will always give you a constant value. So for x is equal to 1, you're always getting c. Let's suppose c is over here. For x is equal to 2, you're always getting c. For all the values of x, you're getting c. So therefore, we'll get such graph. This one is origin. This is the origin. This is x-axis. All the values of x go over here. This is fx. Y-axis. All the values of fx go over here. So this is the graph of constant function. So the domain of this function will be all real numbers, because there is no restriction of any kind that you cannot substitute such value or any other value. But the range will be, what is the range?
C.
Just C. Because you're getting only one answer, only one value. For all the values of x, that is equal to C. Next is, okay, codomain can vary. It can vary from question to question. So next is identity function. So identity function is fx is equal to x. So just make the graph of this function fx is equal to x.
X axis है जो x की वैल्यू डाल रहे हैं वही फंक्शन की वैल्यू है
स्ट्रेट लाइन कैसी?
ऐसे
हो गया? So you get, for x is equal to 1, you get 1. X is equal to 2, you get 2. So 1, 1, 2, 2, 3, 3, minus 1, 1. This is the graph you get. Right? So this is the graph of fx is equal to x. Domain, all real numbers. Range, all real numbers. So this is called identity function, because whatever value you are putting, the answer is the same one. Third is fx is equal to minus x. Can you make this graph? So 1, 1 was a point, 2, 2 was a point. In this case, if you put x is equal to 1, you get minus 1. So 1, minus 1 is a point. 2, minus 2 is a point. Minus 1, 1 is a point. So this line goes like this. So this is a graph fx is equal to minus x. So the domain of this one is the same, all real numbers. Range is also all real numbers. How do we check the domain? By checking all the values of x-axis, which can be substituted. And for the range, you check all the answers you are getting. So you're getting answers all over the y-axis. Therefore, the range is also all real numbers. Next one is very important, modulus function. So it is a combination of these two functions which we have made. So let's first define modulus function. Fx is equal to modulus x. So you must have seen the symbol. This makes a negative number positive and positive remains positive. So this is actually the absolute value of a given number, you can say, or a given function. So this is also called absolute function. If you have fx is equal to mod x, this is equal to plus x when x greater than equal to 0. So this is equal to x when x greater than equal to 0 and minus x when x less than 0. Okay. So the graph for this one will be, now see, for x greater than equal to 0, it is satisfying fx is equal to x. So for all the numbers which are greater than 0, it will satisfy the graph of this one. For all the numbers less than 0, it will satisfy the graph of minus x. So it is a V-shaped graph. Goes like this. So this is the graph of modulus function. And the negative portion remains untouched. So the domain here will be same. So there are two ways of writing the domain. Either you can write R or you can say minus infinity to infinity. Same thing. Codomain can also be R in this case. But the range, this is important thing, range will be, yeah, so it will be from 0 to infinity. Either you can write it like this or
I plus
positive real numbers including 0. R plus union 0. बताता हूँ. Understood? So let's see what is the meaning of the definition fx is equal to mod x. So let's suppose I have two numbers. First one is x is equal to 3 and second one is x is equal to minus 3, right? So I take mod of these two. So first case I take mod of 3. What do I get? 3, which is further equal to x. This is the same as x. If I take modulus of this, I will get modulus of minus 3, which is equal to 3, which can be written like this: minus of minus 3, which is equal to. Now just remember that the value of x is negative. Now since value of x is negative, I have to put one more negative sign over here so that I can make it positive. When x is less than 0, that's why we put a negative sign in front. So mod x is equal to minus x when x is less than 0. So this is a modulus function. Next we have signum function. Have you studied this one? 11th standard? Next is signum function. The fifth one. So signum function is written like this: fx is equal to sgn of x, sgn, right? It's not sgnm. Sgn of x, signum of x. Or the other definition is like this: fx is equal to mod x upon x when x is not equal to 0 and 0 when x is equal to 0. So this is the definition of signum function. Can you make the graph for this one? Just make it. Or you can also say that this is equal to -1 when x less than 0, 0 when x is equal to 0, 1 x greater than 0. So for 0, it gives you 0. For x is greater than 0, you always get 1. X less than 0, you always get -1. So this one is the graph. So this is origin. These are the values of x. This is the value of fx. And this one is the graph. So what do you mean by this hollow dots and solid dot?
Not included.
Yeah. So this point is not included. This is not included. This one is included. So at x is equal to 0, you're getting value 0. For all the positive numbers, you're getting 1. And for negative numbers, you're getting -1. So the domain here is all real numbers. And the range consists of 3 elements, -1, 0 and 1. Written. What if I give you only this function? Can you tell me what happens here? Fx is just equal to mod x upon x. So what is the domain? All real numbers.
All the numbers except 0.
Except 0. So the domain here will be, so this is another sixth, fx is just equal to mod x upon x. So the domain here is all real numbers except 0. So this is a difference of sets. You must have studied this. What do you mean by difference of sets? You just eliminate this part from all the real numbers. So all the real numbers except 0, and the range here is just -1 and 1 because you are not getting 0. But in the case of signum function, we separately define it for 0. That at x is equal to 0, it is equal to 0. So this one is not a signum function. Fx is equal to mod x. But if along with this, it is written that at x is equal to 0, it is equal to 0, then it is. So next, write down power function. Now the codomain of 99% of the cases is all real numbers, unless it is mentioned otherwise. If, like in the question, it will be given that the function is defined from R to R, or let's say R plus 2 R, then the first one is called the domain and the second one is codomain. So it will be either mentioned in the question. If this is not mentioned, then the codomain will be all real numbers. So now let's see the power function. हाँ बताओ.
यहाँ पे अपने रेंज में -1 0 1 लिखा, तो यहाँ पे हमने -1 और 1 को इंक्लूड नहीं करा.
दे आर इंक्लूडेड इन सारी वैल्यूज पे तो 1 ही आ रहा है, इन सारी वैल्यूज पे -1 आ रहा है।
ये x की ये तो y की वैल्यू है, y इसमें से या तो फिर भी ये हॉलो सर्कल क्यों बनाया?
क्योंकि उस x इज इक्वल टू 0 पे वो -1 या 1 नहीं है, बाकी सारी वैल्यूज के लिए है। एनी कंफ्यूजन टिल हियर? श्योर? नेक्स्ट इज पावर फंक्शन. Power function is x to the power n. So you have fx is equal to fx is equal to x to the power n. So we'll discuss two cases. First, when n is even, n is odd. Have you done this thing? What happens when n is even and when n is odd? So you must have an idea, I guess. So let's see the most basic example of fx is equal to x square. So at x is equal to 0, the value is 0. X is equal to 1, the value is 1. X is equal to 2 पे 4. Right? So the graph moves like this. Similarly for negative values, so this is 1 and this is 2. Okay? Similarly for negative values, let's suppose -1. I will get the same value 1. -1 square is +1. And for 2, again I get 4. So the graph is such a U-shaped graph. It just make it U-shape. Like this. So this is a graph, and when n is odd, in that case the graph will be pretty different. It will go like this. Let's see why. At x is equal to 1, you're getting 1. At x is equal to 2, you get 8. So let's suppose this value is 8, right? And similarly, at x is equal to -1, you get -1. And at x is equal to -2, you get -8. So that is the difference between x square and x cube, right? So this one is fx is equal to x cube, and that one was fx is equal to x square. So for all the even powers, the graph always is U-shaped. For all the odd powers, it always goes like this, smooth curve. Okay? Just make these, and then we'll join these two graphs, combine these two things. If we join these two graphs on a single one, so this is 1, this is 1, and okay, no. And similarly, so the graph of x square, if it goes like this, then the graph of x cube will go like this. and the graph of x to the power 4 will go like this. Okay, very bad. So the first graph is, let's suppose, the second, the third. Similarly here, if you have x square, this will be x to the power 4, and this will be x cube. So just see the graph of x square so for all the values fx is equal to x to the power n. After putting x is equal to 1, you will always get 1, right? So all these graphs meet at this point, which is 1 comma 1. Is this clear? But the difference arises when you put the values greater than 1. Let's suppose you're putting value 2. For x square, what will you get? You will get this one, this value. For x cube, you will get this value, x cube. And for x to the power 4, you will get this value. So for x is equal to 2, the value keeps increasing, because here you're getting 4, here you're getting 8, and here you're getting 16, right? So what we can say is, as n increases, now this is the symbol of increasing arrow, the graph moves inwards.
towards the y.
Okay.
दोनों x की direction है. Since we have positive x वाली direction में inwards जाएगा.
इधर से भी same, यहाँ से भी same, because if you put the value -2, you will get 4, and here you get 16. So these are the two graphs, x square, x to the power 4, and x cube is this one. So in this case also, as n increases, graph moves inwards. Except this portion from 0 to 1. In this case, as n increases, graph moves outwards. So let's study this by an example. Let's suppose x is equal to 0.1. So x square will be 0.01, x cube will be 0.001, and one more 0. So the value of fx is decreasing in this case. As the value of n is increasing, as you are increasing the power on x, the value of x to the power n will be decreasing. It will be falling down. So therefore the graph is moving outwards in this case. Understood? So in this portion also the same thing, the same story. So after 1, for all the values, or you can say define it like this, for mod x greater than 1, the graph moves inwards as n increases, while for mod x less than 1, graph moves outwards. So the graph of x square is going like this. The graph of x cube will go below from here but above after x1. So before x is equal to 1 it will be below, but after x is equal to 1 it will pick up and will be above the graph. So understood? Power function is clear. So we can say that the power function can actually be of two types. First one is fx is equal to x to the power 2n, and another one is fx is equal to x to the power 2n plus 1. So first is fx is equal to 2 to the power x to the power 2n. This is when the power is even. So in this case the domain will be all real numbers and the range will be 0 to infinity, because you are not getting any negative answers. If you have x to the power 2n plus 1, domain will be all real numbers, range all real numbers. Okay. After this, the eighth function is greatest integer function. Have you studied this one? Okay. So the symbol for greatest integer function is so this is fx is equal to square brackets and then x. So this function is also known as greatest integer function or the floor function or the step function or the integral part function. These are all the names. So actually for integer function we have two different functions, floor function and ceiling function. So what do we mean by floor and ceiling? Let's suppose 3.6. Okay. Actually we have first function like this and the other one like this. Right? So floor function means we have to check the integer which is lower than 3.6, which is 3. And ceiling function means we have to check the upper integer. So this is floor function and this is ceiling function. But actually we just have to study floor function and we put this bracket, standard brackets. Or this is not in the syllabus. So written. So first what you need to study is that every number can be written as a sum of integral part and fractional part. So let's suppose we take a number like x. This can be written like this, box x plus fractional part of x. So this is a representation of x. So this is the integral part and the other one is the fractional part. So this will be I plus f, integral part plus fractional part. So this fractional part always lies between 0 to 1. Now this is a fraction lesser than 1, like 0 0.5, 0 0.9, something like that. It cannot be negative, it lies between 0 to 1. So if you have minus 3.6, what can you write this as? What is the greatest integer function of minus 3.6?
-2.
Minus 2. No.
Negative
Minus 3. Minus 4. Which one is the answer?
तो नेगेटिव में जितना बड़ा होगा छोटा होता है तो इसलिए -2 होगा
So it is the floor function. So you have to check the previous integer. That will be minus 4. So answer will be minus 4. No? Because you can write this as minus 4 plus 0.4. Then it will make sense because the fractional part will be lying between 0 to 1. If you write this as minus 3, you will have to write minus 0.6. Okay, this is wrong. So minus 4 plus 0.4. So the definition of greatest integer function will be that it is the greatest integer lesser than or equal to given number. So this one is the definition. Greatest integer lesser than or equal to the given number. Can you try to make the graph of this? Do you know how to make it? Just try.
फ्लोर फंक्शन देखें तो अगर 1.9 है तो वहाँ तक की वैल्यू 1 ही आएगी और फिर 2 से लेके 2.9 तक भी 2 ही रहेगी
हो गया? So for all the values from 0 and before 1, it will be 0. Like 0.1, 0.2, 0.9, it will be equal to 0. But at x is equal to 1, it will not be equal to 0, it will be equal to 1. Because the definition says that it is the greatest integer lesser than or equal to the given number. Because we just have to check the integer. If the function is already integer, you don't need to check the previous integer. So from 1 to 2, it will be equal to 1. So from 1 to 1.99 and so on, right? For the number previous, just previous to the 2, it will be 1. And similarly, next it will be 2. Next 3. And so on. Similarly in the negative case, so since the graph says of the form of step, it is called a step function, right? So at 3, it will be equal to 3, not 2. So that's why I put hollow dots here and solid dots here. So write down the domain. What is the domain? All real numbers. There is no restriction in fx is equal to GIF of x. And in the case of range, what is the range? All integers, you can say. What is the representation of integers, z or I? Same thing. How do you represent rational numbers? Q. Yeah. So z is for integers. Right. Next is fractional part function. So fractional part function is this one, curly bracket x, and it means that you have to write the fraction. Like if it is written 1.3, fraction part function will be 0.3. If you have minus 9.7, what is the fraction part? Can you tell me? 0.3. Because minus 9.7
can be written as 10
minus 10
plus 0.3.
plus 0.3. So minus 10 will be greatest integer function, and this is the fraction part function. Right? So how to make the graph of this one? For all the numbers lying between 0 to 1, fraction part will be equal to the number itself, right? So here it will be equal to 0, 0.5, 0.9 and so on. When we reach 1, now 1 has no fractional part, therefore the fractional part of 1 will be 0. And after that you will get such things, right? And it will go on like this. Got this one? Like at 1.5, the fractional part is same as the fractional part of 0.5. At 2.5, 3.5, all the fractional parts are same. So the graph is going like this. Right? Okay, what is the domain? All real numbers. And what is the range?
0 से 0 included होगा और 1 excluded.
Range is 0 to 1. And 0 is included, 1 is not included. This one was 9th. Next is reciprocal function. So reciprocal function, the name itself is self-explanatory, that fx is equal to 1 upon x. This is the reciprocal function. So if you put the value of x is equal to 2, you will get fx is equal to 0.5 or half. If you put x is equal to 4,
0.25.
fx is equal to 1 upon 4. So we'll come to this graph. Let's first see the graph of fractional part function again. So see, for value, let's say 0.2 or 0.9, the fractional part is same, that is equal to 0.2 or 0.9. So the graph is linear like this, right? It is increasing constantly. For 0.2 you are getting 0.2, for 0.9 you are getting 0.9. Once you reach x is equal to 1, as you reach x is equal to 1, the fractional part of 1 is equal to 0. What is the fractional part of 1.1? This is equal to 0.1 again. So it will again start from x is this fx is equal to 0 and go like this up till x is equal to 2, because when you reach 2, the fractional part will be equal to 0, and when you get 2.9, the fractional part is equal to again 0.9. Then again it will start like this and it will keep going like this. And in the negative cases also it goes like this. Like if you have minus 1, the fractional part is 0. If you have minus 0.8, the fractional part will be 0.2. For minus 0.9, minus 0.1, the fraction part will be 0.9. So it goes like this, right? So this is the graph of fraction part function. Next is reciprocal function. Now in the case of reciprocal function, for all the values of x greater than 1, fx will be smaller than 1. Just see this very carefully. As you keep increasing the value of x, fx keeps decreasing. And similarly for all x less than 1, fx is greater than 1. And this also applies for negative values. So that's why we can put mod with here. So let's see the graph of this one. If you put x is equal to 1 in this function, you will get 1. So for x is equal to 1, you are getting 1. For x is equal to 2, what are you getting? 1 by 2, right? For x is equal to 3, you are getting much smaller value. For x is equal to 4, again smaller value. So the graph is going like this. So it keeps decreasing. No? Is it okay? Do you understand this? As you increase the value of x, this becomes 1 upon x, decreases. So that's why the value keeps decreasing. But as you put the values which are smaller than x is equal to 1, like let's suppose you put half, what will you get? You will get 2. So at half you are getting 2. Similarly at 1 upon 10, what are you getting? 10. So in this case the graph goes like this, right? So this is the graph of reciprocal function. And in the case of negative, if you have minus 1 upon 2, right? If you have x is equal to minus 2, you will get minus 1 upon 2. So the graph will be exact same image of this one in the third quadrant. So it will go like this. So this is x is equal to 1, y is equal to 1. Understood? So these are the two graphs of reciprocal function. Actually these graphs are known as, yeah, you can, no. hyperbola. This is a hyperbola. These two are hyperbolas. You must have studied this kind of hyperbola. I think I taught you. xy is equal to 1. Remember? xy is equal to c square type. Rectangular hyperbola, yes, specifically. So this is the graph of rectangular hyperbola. Now hyperbola always has two branches. In this case, the first branch lies in the first quadrant and second branch lies in the third quadrant, right? So this is the definition of reciprocal function. Can you tell me what is the domain of this reciprocal function?
All real number except 0.
Good. So the domain here will be all real numbers except 0, because when you substitute 0, you will get not defined. And range is also the same, all real numbers except 0. Because you never get the answer 0, you will get answer slightly greater than 0, slightly lesser than 0, but never 0. Okay, is this clear? So let's wrap it up over here today. So we'll continue from this next time.